Thank you, Ajay. I think that broadly set the context because while as a technology institute we focus on technology, there are so many interlinking elements that needs to come together for anything substantive to happen. And I'm glad that you brought the point specifically as to how academia can work together. And I'm also glad that it covers beyond developing technology. It has an element of evangelization and capacity building, which we should be happy to take up. Now, I'd like to call upon Mr. Autif from IFC. So, the question I had posed him was most commercial building stock in India, as you would all know, is likely to be built in the years to come, a lot of infrastructure. And what are the challenges that is seen by him working in this space in improving building efficiency? And more importantly, the question I had asked is, and this is something some of my civil engineering colleagues told me, is there is no motivation in building a better building because most of the value in a building is in the land in India. Building per se contributes to no more than 15% of the value. So here the question is, are there any prototypical buildings that are there in India? But more importantly, is the building sector intrinsically motivated to maintain a high performance building? So, over to you.
Good afternoon, everyone. Thanks, Satya, and thanks, Nikhil. So I work for International Finance Corporation, which is part of the World Bank Group. World Bank Group, as you commonly know, is the big organization that gives money, grants for like roads and huge projects. But we also have a private sector arm, which is what IFC is, where we deal with private institutions, companies, corporations, and not just for investment, but also for technical support. And we've identified a few key sectors that are key for the economic development of the developing countries, including India. And one of those sectors is the building sector. So I'm going to talk about that, what we are doing in the green building space in India, and why is it important, and try to answer Satya's questions along the way. So we all know about India's target on 2070. Now, a lot of people say it should be earlier, but from the buildings perspective, I feel we can get there much earlier because buildings are relatively an easier sector to decarbonize. Because once you design and build a building correctly, appropriately, then it is there for 30, 40, 50 years. You don't have to do a lot of tweaking if the systems are built right in the first place. So it's relatively easy as compared to, let's say, solar, agriculture, transport. These are, or industry, these are much more complex buildings or systems than the building sector itself. So we actually still need to build a lot of buildings. Our cities are still urbanizing, people are coming in. Our housing the demand is not fulfilled yet. So we need a lot more construction to happen. Now, when that construction happens, we are obviously increasing greenhouse gas emissions for the construction itself and for the operation, and maybe even for the demolition once that happens. So how can we build these buildings in a way that it doesn't really cause a huge burden on an environment and still helps us meet that 2070 target or even an earlier target that we have? So the question is that Satya asked is, why is not everybody already building green? What is the kind of reason why people are hesitating, especially in the commercial space? So I see three main reasons. First is what? What exactly is a green building? What exactly is energy efficiency? For many people, these are kind of ambiguous terms without any clear definition. So trying to establish that clear definition, clear quantified target, I feel is the first step. The second step is why? What is the benefit? What is the business case behind doing this? So trying to establish that business case, and that business case will be different for every kind of stakeholder. For the building owner, it will be different. For the building operator, it might be different. Building investor might be different. The building occupant, it might be different. The government, it might be different. So we need to find the right business case and make it well known, spread the awareness, and give some good examples. And third is, once you've been committed, you're convinced that yes, there is a strong business case, I should do it. How do I do it? what are the kind of technologies, design features I need to include in my building, and then how do I finance it? So that how is also sometimes a barrier to building green. So let me try to very quickly address how we are focusing on the answers to these questions, and maybe others can also look at it in that perspective. So firstly, the definition itself. What exactly is a green building? Now, green is sort of like asking people, are you healthy? What exactly is good health? There are different definitions. So we need to establish a very clear definition of good health, and similarly for good a green building. So very roughly speaking, a green building is a building that fulfills the client's needs. So like provides sufficient space, the programmatic needs, including indoor comfort, thermal comfort, visual comfort, etc. So it fulfills those needs, doesn't compromise, but without harming the environment, without using too much energy, too many resources to fulfill the needs to build it and operate it. So that's kind of the high level definition. But if we dig deeper, what we've come up with is a very quantifiable definition. We say that a building that uses 20% less energy, 20% less water, and 20% less embodied energy of construction materials as compared to a local baseline is the minimum level of compliance with green standards. So let me explain what we mean by this. 20% less or 20% better is really comparing against its peers. So if you're evaluating an office building in Chennai, it should be compared against how other office buildings in Chennai are being built nowadays. The standard, the business as usual practice. So if your building is at least 20% better than your peers, then we say, yes, you are green. And that standard or business as usual should keep changing every 3 to 4 years. One example is lighting. About 5 years ago, LEDs were not very common. LED lights were expensive and not everybody was using, but now you see them everywhere. So that's the baseline now. So lighting energy has significantly dropped over the last few years. So so now we are saying you need to be at least 20% better than that new normal. Only then will you be considered green. Similarly for water and for embodied energy, which is kind of a ignored child of efficiency or sustainability, because embodied energy is not clearly visible to us. Embodied energy is another way of saying manufacturing energy. So let's take the example of bricks. Red bricks, common red bricks. How are they manufactured? Somebody extracts clay from the soil, they burn it in a kiln, in an oven, and then they transport it. All these steps require energy. That is embodied energy. Now, instead of burning, if we could come up with a way of making bricks without burning, and there are a lot of ways already out there, then we save embodied energy. So there are alternate materials that kind of reduce or optimize those steps. So that also should be reduced by 20% at least. Because right now, cement manufacturing, brick manufacturing, steel manufacturing, aluminum manufacturing, these four are probably consuming about 15% of global resources, if my numbers are not wrong. So let's take one more step, zero carbon, which is a term that you've already heard today, and many people would already be working on this. What exactly is zero carbon? Some people call it net zero, some call it net zero energy. We are using the term zero carbon because ultimately now everything is boiling down to carbon. How much carbon are you burning to meet your energy needs? So zero carbon really means that your net impact on the environment in terms of carbon emissions is zero. So you're firstly reducing your energy consumption by a certain minimum number. We put in a 40% reduction. So that means for a building to be zero carbon, firstly reduce its energy consumption by at least 40%. And then whatever remains of the energy demand, you supply from renewables. Then that building is zero carbon. So the next question was why? Why should they do it? What's in it for them? And there are multiple answers to this. We already heard from Ajay about BRSR, the ESG requirements. Now these are coming in, and right now it's only top 10,000 companies and top 150 private companies, but this will start to percolate down to other companies as well. So if we're not monitoring, not managing our carbon emissions, our energy consumption, etc., we won't be able to follow this requirement, which obviously will lead to other repercussions. Governments are also doing something like this. In the UK, they've said that if you don't have a carbon reduction plan, we won't give you business. That's a very strong disincentive. So, if you look at the benefits, the key benefits are obviously lower operating costs, which is what most people generally talk about, which is a very important one. But for many buildings, actually, that's not the key driver. For many building operators, like if I'm a developer constructing a building, an apartment building to sell, I don't care about operational costs. So we should look at all the other factors and try to pick up the one that affects them the most. So access to green finance is a very strong one. Now, a lot of finance is made available in India and globally to projects that have a certain minimum climate improvement capability or possibility. That has to be verified, and I'll talk more about that later. And that can become like a huge driver, a huge catalyst for green buildings. Now, let's consider two scenarios. A builder who's not building green, does not follow any green standards, and one who does. What happens to them? With the first builder, their capital cost is just whatever is normal in the market, but the operational cost can keep going up because the tariffs are going up. The energy prices, water prices are going up. So that will keep going up. The occupant comfort may be impacted because now people are more aware, especially after COVID. They want their environment, indoor environment, to be healthy and productive. So that will become a drawback. Marketability, because people won't like to be in those buildings, it will be difficult to rent out or sell out those buildings. The value might go down as well. And the resilience, the climate resilience, because now, like Chennai saw the floods a few years ago, Bangalore saw them, and a few other cities. Now those kind of issues might keep increasing because of the climate change. And if our building is not built to be resilient, it will again face certain problems. And lastly, access to finance, which I already mentioned. And so let's take the second scenario, a green building. So an ideal green building would not just put a huge solar panel on the roof and say we are green because we are meeting all our needs from solar. That is a very kind of a counterproductive approach. The right approach in our mind is this hierarchy, that you try to reduce your demand first, demand for energy, demand for water. And how can you do that? By using natural things, like use natural light, use capture rainwater, treat your recycled water, and use it in the building. By reducing the demand first, and then whatever demand is left, meet it with efficient equipment. And once that's done, supply or run those efficient equipment with renewable energy. So that will give you the best returns on your investment. So if we do that, then this developer number two would have a lower capital cost in many cases. Because what happens when you use natural resources or reduce your demand, your chiller equipment, your lighting equipment can be smaller. You don't need 100-ton chiller. Maybe you can make do with 75-ton. So your capital cost can also go down. And if designed well, occupant comfort will go up, marketability will go up, and access to climate finance can also be improved. So if you're not trying to, or planning to become obsolete, then you should definitely look at green buildings. Now, how do we do it? This is often people are afraid of getting into the technicality, saying it's a very complex field. It's actually not. It's simple science. If we do it one step at a time, we can actually do it fairly quickly, fairly easily. That's the approach we've taken with our EDGE program, which Satya had mentioned earlier. We've come up with this program to help individual building owners, architects, engineers, investors, operators to figure out the optimum mix of measures, technical measures to make their building green, along with the cost associated. So the edge systems works like this: that you go to a website, edgebuildings.com. I will show you some screenshots after this. www.edgebuildings with an S at the end, buildings.com. It's a free app. It's a cloud based online platform with data for every single country in the world. And within India, we've got data for about 65 cities and for about 8 different building types. So you go in there, select your city, select your building type, enter basic dimensions of the building, basic operational requirements, how many people, what is the square foot, etc., etc. And within an hour or two, you'll be able to figure out how your building performs as compared to the local baseline and whether it's meeting the 2020 requirement or not. Once you meet the 2020 requirement, then the next step is to get it verified so that you can go to the financier, you can go to the market and sell your building as a green building. And with financiers, you may be able to get access to climate finance. So you have an auditing process. So the three standards or the three levels of compliance, one is the basic 2020, but we want people to go beyond that. And if we achieve at least 40% reduction in energy saving, that is a platform for zero carbon. Because then after 40%, if you can meet the rest with renewable, then that can be classified as a zero carbon building. And that there are of many benefits to this, not just savings, but also some of those other benefits. And now we have some examples, real life examples. I'll show one later of such buildings. So these are some screenshots of the app, the Edge Buildings app. So again, the website was edgebuildings.com. Sorry. So you go there, you select your building type. On the left, there are 7-8 building types. Select your location. India, we have selected Chennai, and we have selected a warehouse. And put in some basic dimensions of the warehouse, how long it will be used, what is the size, etc. And it will extract the business as usual data from the database. So we've already populated how typical warehouses in Chennai are being built nowadays. That's already in there. It extracts the data and calculates the business as usual energy performance for your building. If your building had no green features, how much energy would it use to operate? So it tells you on the bar on the left is the business as usual energy use, along with the breakup where that energy might go in. So you're getting this information instantly almost just by plugging in some basic dimensions of your building. And then it gives you opportunity to look at all these measures, improvement measures, and create any combination of measures. There's no mandate. There's no requirement that you have to have this kind of a light or you have to have this kind of a window. Do anything you want as long as the performance is at least 20% better. The software helps you figure that combination, your own unique combination out. And as long as you meet this number is at least 20, then you meet the energy requirement. Similarly, we have this is carbon calculations, and we have water calculations. So for water, it tells you where the base case or the business as usual water consumption would be. And there are linkages between energy and water, because you have all the pumps running to supply the water. And if you have hot water in the building, you have a geyser which is providing that. So that also is added in here. Then embodied energy, also looking at how much wall volume you have, how many slabs you have. It calculates the embodied energy, and then you can try out different materials or even thickness of materials. What if I change my exterior wall from 250 mm to 120 mm? Or what if I change my slab to have fly ash cement in it? So it gives you real time information on that. And while you're doing all of that, it also at the top gives you all this information: the overall energy impact, water impact, carbon emission impact, operational energy, operational cost impact. how much money are you going to reduce on your electricity and water bills? And very importantly, for investors and developers, what is the capital cost? So you can do a payback calculations in real time and figure out if you are comfortable with that. So now we are taking that approach and trying to help portfolios, large building owners, campuses, etc., decarbonize their entire building stock in a phased manner, starting with new construction, but gradually going to existing buildings as well, so that we can find the right kind of retrofit opportunities for those buildings as well. So we are a financial institution ourselves, and we have very closely aligned with these international climate finance standards. So that means if you're looking for climate finance, whether it's from IFC or from any other international or major investor, Edge would help you meet some of those requirements. And this is just showing the availability of climate finance, how that's increasing. And I only have 2019 numbers in this graph, but actually it's grown up. Even during the COVID era, climate finance kept improving. So we're working with Edge across the country, all types of buildings, industrial, educational, housing. Affordable housing is an interesting one. Even self-built housing, individual homes that people are building themselves, even without an architect. We're working with them as well, and right up to the luxury hotels, apartments, etc. So on our website, if you go, you'll see examples of all kinds of buildings, including some very interesting high performing buildings like this one, which is here in Chennai. This is Tata Realty's Ramanujan IT Park. This is our first zero carbon building in India. It's a campus with about 7 buildings, older buildings, but they retrofitted and then they supplied renewable energy, and then now it has zero net impact on the environment in terms of carbon emissions. So I think this is definitely possible. In fact, just 2 days ago, we got a certification for a zero carbon residential project, so in Chandigarh. So now it's actually being demonstrated across different building types as well. So I'll stop there, and later I can maybe take questions. Thank you so much.